Dear fellow coders, welcome to Untitled Coder. This is day 12 of Kaggle's 30 Days of Machine Learning Challenge, and in this video we're going to jump into intermediate machine learning course. So if you're new here, we have already covered basics of Python, and then we have also covered introduction to machine learning. So let's get started with the first tutorial, in which we are going to learn a little bit about what this course covers, and then we are going to learn about missing values, how to handle them, like what kind of functions or code that we have to use, and then finally we're going to look into categorical variables. So let's get started. If you do not have a Kaggle account, or if you are not signed in, so you should look at our first video, which day zero's video, in which I've talked about this stuff. So the first lesson of intermediate machine learning micro course, this talks about what are the things that you need to know to accelerate your machine learning expertise. Like after you have already done the introduction, so the thing that you need to learn that you would often face in a real world data set is handling missing values, handling categorical variables, design pipelines to improve the quality of machine learning code. So instead of just, if you want to like build multiple models or something like that, so having pipeline would help you. And the most important thing is having a good cross validation strategy, which is like slightly more advanced. So far we had done train and test data split for 70%, 20%, something like that. But having better cross validation strategy would help us to have a better machine learning model, a robust machine learning model, a model that doesn't go off it. Also, we can learn how to build state-of-the-art models. Maybe state-of-the-art model may not be a relevant word for XGBoost at this point in the world, but again, still XGBoost still rules in a lot of tabular computation. So you should definitely check out XGBoost in this section. Finally, we would learn about leakage. What is especially data leakage in terms of data science problem, especially if you look at Kaggle, what kind of data leakage things can happen, especially in a Kaggle computation, and how it can impact. So these are the things that will be covered in this series: missing values, categorical variables, pipelines, cross validation, XGBoost, and data leakage. And now, so what we have done so far is we have already done a simple hands-on exercise with the house price computation. So now what we are going to do is we are going to get into the exercise and learn about what is there for us, like a quick check. So I am not exactly sure where we are, but if you remember, previously we learned about model validation, underfitting, overfitting, and random forest, and we also implemented random forest in the housing price computation, and then we submitted the solution. I've got my Kaggle notebook, which is a part of an exercise. Start the machine. Once the machine is done, then I'm going to run this thing, which I've already done. After that, we can look at this code. So what do we have in this code? We have pandas for data manipulation, train and test split for model selection, and then read the train data, read the test data. Once we have the train and test data, then we are going to obtain our target and predictors. First get the features, it's a string list, and then we are going to extract the features from this column, like this x test full, this x full. And it's slightly a weird name, but again, yeah, I think it works fine. And because we have run this thing, let's run. So now then we are going to break it into multiple validation data set. Like for example, train size is 80%, test size is 20%. This test is different from this test. That's something you might know. This test that we are creating is from our training data set, because we want to validate whether a model overfits, and then we want to proceed further. So we have successfully ran. Look at our training head. So this is our head. It looks like this, and these are the columns that we have got. And now what we are going to do is we are going to build a different set of random forest models. For example, so we have a random forest model with number of estimators 50, random state is 0. So we are going to use random state 0 for everything, just in case, like if we want to replicate the result, we can do that. So now we have got 5 models, so different estimators, 50, 100, 100, with the different conditions saying that mean absolute error is our criteria, and then 200, and then controlling another hyperparameter tuning, which is to say the number of sample split, minimum sample split driven, and also we are trying to control the depth. So we have 5 different models, and the easiest way for you to learn about these parameters is either you go here and then say help of the better way is to go to scikit-learn documentation, but if you want to do it, you can just simply say like this, Oh, we have not defined it because we have not imported this. If I import this and then do this thing, you would get an understanding about what every attribute does. But the best way to do that is you go and say scikit-learn documentation, and then you type this, and then you would get this documentation, and then you can read more about it. It's the same thing, but it is more readable. Now that we know how to understand these parameters, let's run this thing. So we have at this point defined 5 models. If you do not remember, the steps that we usually have is first define the model, fit the model, predict the values, and evaluate. So this is our simple API that we follow with scikit-learn. Now next that we have defined 5 models, let's scroll down and then start looking at score. And we are going to create a function here, and then the function is to compare our model score. So first attribute of the function score underscore model. So it's a model, the model that we want to watch or we want to check the score for. And then we have the training data set, then we have the validation data set, then we have the training data set, and then we have again like y target predictors and target values. So then what we are going to do is for this model we are going to fit the values, and then we are going to predict, and we are going to return the mean absolute error. So basically this function returns you one single floating point value, which is our mean absolute error. And what we are going to do is we are going to do this for all the models that we have got. If you remember, our models is models is a list of models that we have already defined. So we are going to repeat it for individual models. So that's what we are just saying, that for I in the range of 0 to, let's say, length of model in this case would be, because we have got 5 models, 5. So for 5 we are going to do this 0th, 1st, 2nd, and then for everything we are going to score the model, get the result, and print the result. So at the end of the step you would see 5 print statements. Okay, so first one, second one, the third one is executing, fourth one, fifth one. So you can see probably the best is somewhere here, the third model, which is quickly check. I should probably do this. The third model, which is 100 estimators, and where we have specified that the criterion, which is our evaluation metric, is mean absolute error. So now there are many different ways for us to evaluate the model, which one, like to find out which one is the best model. So like in this case we can actually manually look at it and say, but if you really want it, the simplest way, what I would do is I would actually create an empty dictionary. So let's say I would call it MAE is equal to, sorry, did I say empty dictionary? I would say MAE, and then I would I can, for the least value I can print. So if you remember what we did in the previous exercise, we try to put that value, like the model MAE, and also we try to put whatever it is the score, so we can find the minimum value, and then that's how we can find. But right now we know what it is, so which is the least error of all these things, which is model 3. So I can say model 3, run it, correct answer. So next, generate test predictions with the model. So now that we have already defined and we know which model is good, so we can just copy that model, in this case this, and then come back and then say this is my model, this is the model that I have got, the best one. So okay, we have assigned it to my model, our answer is right. And then the next thing is, for my model we are going to fit with the entire training data set. So if you remember previously, we were trying to use the test and train split data set because we wanted to find the best model that doesn't overfit. But now that we have already identified the best model that doesn't overfit, we are going to fit it with the entire data set, so we can submit the predictions for, or get the predictions for our entire test data set. So fit, predict, and then once you have that, you are going to say submission.csv, and then we can submit our result. So like I said, you can either download the CSV and then submit, or you can actually say save this, and then once this thing runs, you can go to that notebook, which I'll just show you in a couple of seconds after this runs there, and then you can click the submit button. So if you want to quickly check one more thing, so you can actually see where have we landed in the computation before. So if I go click the computation, And then if I see the leaderboard, last time when we did, this was our score. And where are we? When we go to the leaderboard, I think we were somewhere, okay, we are somewhere around 12,000. That was our position when we did this thing. So now let's see how much we are going to improve. And if you notice, what are the changes that we have done? The changes that we have done is we have done hyperparameter tuning. We try to change the split with slightly more descriptive detail about what is the split that we want. And then the next thing is we try to use different kinds of models, like same random forest regressor but different hyperparameters, so more like, you know, brute force hyperparameter tuning. And then finally we picked up the right model, or the most scoring model, highest scoring model, and then we have calculated all these things with that. So let's see how much rank improves. Now it is successful. Click this link, it will take you to the notebook which is successfully ran. And then when you go to the section which is especially like output section, you get to see the submit button. Click the submit button. So did I just click it? Click the submit button, and then this is our second version, random forest hyperparameter tuned version 1.0. Okay, let's submit it. Okay, it is being scored. When we go to the leaderboard, you can see that it is being scored. Now it is being scored, so you can go see how much we have jumped. So our previous score was somewhere around 21,000 ish. Now we have come around 20,000 ish, and you can see that from around 12,000 ish we have improved. And you can actually see how a minimal improvement in our final score has actually resulted in a huge improvement, in a huge jump in the leaderboard. And that's what everything is about. Like if you see the top ones, you would see very minute differences. Even if you go to any active competition, you would see the same thing, very minute differences between two teams or individual competitors, and then you would see such an improvement even if you can improve a little bit. So that takes us to the end of the first section. So we have already finished the exercise. Now we are going to jump into the next section, or if you are going to look at the YouTube description, I would paste this link there where you can go and click this read tutorial. And now this is the second lesson in intermediate machine learning, and in this we are going to learn how to deal with missing values. So now, before even we see how to deal with missing values, now what is missing value? What is missing value is, and value doesn't exist here, you know, like it's like the default answer that anybody would give. What is missing value is, missing value is really nothing but when the value is supposed to exist but it doesn't exist. To give you an example, let's say somebody goes to survey the house owners, and then they want to get the value. So for example, for every bedroom, let's say you want to calculate the size of the bedroom, and now you have got a column that says third bedroom size. But what if some house does not have a third bedroom size? So now you have to leave it empty. You have to say that this value does not exist. That is an example of missing value. Or another example is, like, let's say that we are doing a survey where we are asking about income. That's not a mandatory field, and then the survey respondent has not given a income. Now you cannot say their income is 0, because if you say income is 0, that means they are making $0 or 0 Indian rupees. So it's like that, but it is not right. So because of that, what we do is we make it missing value. And what is missing value? It's basically we use null, NaN. So depending upon the programming language that you have, missing value, the way it is being represented might differ. So in this case, we have NaN. So this is how missing values look. So now that we know missing value is thing, now you can think how missing values might influence your model building. Now before we know that we have to treat missing values, first let's understand why do we have to treat missing values. The reason why we have to treat missing value is that most of the machine learning libraries, forget about the super awesome libraries like random forest, XGBoost, LightGBM, forget about these libraries. Most of the classical machine learning libraries would throw you an error if you try to build a model with a missing value, and that is why we need to treat missing value. The second reason is, if you leave missing value open, ambiguous, if you do not treat it yourself, you may not exactly know how the machine learning model has treated that missing value. So it is always better if you also can treat the missing value and then give the model the data set without a missing value. Basically remove all the NAs. When I say remove, there are different ways to remove that, and we are going to look at what to do about that. So okay, so now let's get started with our strategies to approach missing value. So the first simplest approach everybody would say is, oh, you've got missing values, just drop the values, drop the columns. Like this is almost the default answer. Like if you are a data science enthusiast, aspiring data science novice, you would probably hear this a lot. Okay, you've got missing values, just leave the missing values, you shouldn't use the missing value. Now that may look very simple the first sight, but that is not as simple as how it looks. Why? For example, the easiest option in terms of complexity about dealing with missing value is dropping the missing value. That's good enough. But the thing is, when you start dropping missing values, you are also losing important information. So the later section in this current section, we are going to also evaluate these different approaches and also see how the mean absolute error or the score differs for different approaches, that we are going to see. So but the point is, imagine now number of beds is a very important information, and because you have got one missing value, and let's say you have got 10,000 rows, because you have got one missing values, if you are going to leave the entire column, that means like you are actually doing injustice to the data set that you have got. So to avoid that, this is probably your least preferred approach. But yeah, this approach exists, but this is probably should be your least preferred approach. And the second option is called imputation. So simply they call it missing value imputation, which means like you try to fill in the missing value with something. Okay, now you try to fill in the missing value with something. Now what is that something? So by default, a lot of people would say, if you have got a numeric variable, if you have got a number like this, you tend to usually fill it with mean or median, something like this, the average value. Why? Because your assumption is that if it is a sample and this is a true representative of the population, then probably central tendency, which is usually referred by mean, median, mode is mostly like for a categorical variable, but mean, median. So you know that that is what you are going to fill in with. So this is something that people would do a lot. For example, in this case, you can see there is a missing value, and then the mean of 1, 2, 3, which is 6 by 3 is 2. So we have filled it with 2. This is quite common, quite easy in Python, and a lot of people would do that. But again, there are better ways for you to improve the score than just filling it with missing values. And what is the third approach? That is the third approach, where not just simply filling it with missing value, but you also like to create a column where you would say there was a missing value here, and then I fill the missing value. So when your model is actually trying to learn, it might consider this, saying that okay, maybe this data was not part of original information, but maybe there was a missing value, and then like the data scientist or engineer, whoever is handling this, they are filled in with this. So this imputation is a standard approach, but if you want to slightly extend that imputation, this is imputation, it's a standard approach. If you want to slightly extend that imputation, what you can do is you can actually create like a marker or flag that would say that there was originally missing this value, and then we have filled in with something. So in this approach, we fill missing value, but also we create a column where we show that this is a flag and there was a missing value at the start. Now that you have seen three approaches, drop the missing value, impute the missing value, something in most option, like default option, which is mean, and also create an extension to the imputation to refer to what column where there was a missing value and what row there was a missing value. Now that you know all these things, I would like just to quickly say that these are not the only options. There are many approaches. Like if you go to internet and then start looking for missing value imputation, you would actually see tons of articles, a lot of different ways to impute missing values. You should definitely check out these things, and again, it's good to know, like whether you use it, whether you do not use it, it's really good to know. But yeah, don't think that these are the only way to handle missing values. So that's what I'm trying to say here. Now that we know these are the three methods that we can, like simplest methods that we can do missing value, treat missing values or handle missing values. Now let's look at how these things score, like fair. Okay, so now like we saw before, we have our housing data set, we have the same code that we just used, and we also have the same function. We also have the same function where we scored a data set. So instead of scoring a model, we are going to do score data set. You can see the only difference is we don't have the model attribute. Rather than that, we have the score, and we know that we have a random forest model, and for the same random forest model, we are going to score it against different data set. Why different data set? Because we are going to treat missing values with these three different approaches, which means we are going to have three different data set and then we are going to look at it. Now, how are we going to do that? We are going to say the first step is we'll drop the missing values. So this is the first step. So in this case, we are creating the y variable, we are creating the features, and then we have done train and test split. Now that we have the score data set, now we are going to go with the first approach, where the first approach is anywhere. Just look at the list comprehension. Anywhere, if you find null, then you create a data list that says these are the names of the columns that has missing values, and you finally drop them. So basically, first we are trying to extract the column names where is null anywhere, and we are adding that column inside a list that says columns with missing value, and then we are going to drop that column from the main dataset. You can see both in training and test dataset, validation dataset, which is in this case after the split, we are going to remove that, and now we are going to call our function that we created to score the dataset, and then we are seeing the final value, which is MAE, mean absolute error, from approach 1, which is to drop the missing values. Now let's look at the approach 2, which is impute the missing value just with mean. Again, like I said, there are a lot of different ways to impute, a lot of different things that you can impute, but by default we are going with mean because, like I said, it's average, right? So what are we going to do? So what we are going to do is we are going to take a simple approach. There are more complex ways, but we are going to do a simple approach where in scikit-learn, sklearn, impute as a submodule, and inside that you would get a class simple imputer. Once you get simple imputer, first define simple imputer like this, very similar to how you would do your typical scikit-learn API. So then after that you can pass on that value, which is xtrain. So you're trying to say using this object, just fit on this xtrain, and then get the imputed data frame. And then again the same thing for validation. Now that when you do this, your column names will go away for whatever you do, and that column names you are trying to put it back from the original data set. So here we are not dropping the column names, so which means column names are going to be intact, so you can use the column names and add it back. So just dot columns is the attribute for you to display the column names. The same way you can add it back. Now based on the second approach, now you are going to score it again. So you can see the score. The first one is 183,000, second one is 178,000. You can actually already see an improvement in the second method just simply by imputing with mean rather than dropping the columns. Now you know the cost of dropping the column, so that's a good thing. So the third approach is creating an extension. So instead of changing the original data set, because we are going to add a new column, right, what we can do is we can create a copy of our train and validation data set, and then we are going to create a column saying column name where missing value. So we are going to loop it, like we are going to iterate for every column where missing value was there. So we are going to say call underscore missing value, like was missing, and then we are going to say is null will return the boolean value. Is null is going to say whether it missed or no, so that will return a boolean value, true or false, and then we can get the value stored. So basically you are creating a new column just similar to this, and then dynamically you are creating the column name because you have already found out the list of column names with missing values, and then you're going to just append or concatenate this value saying was missing, and then you're going to add boolean values which comes from is null, where is is null, yes, which comes from is null. And then we are going to again do the same imputation that we did before, fit, and then we are going to add the column names back, which is because the column name is removed, and then score the dataset because we have got new datasets. This dataset is what you're giving, and then when we evaluate, this score is not better than, like it's slightly improved, but slightly worse, but it is not any improvement by any chance. So 3 approaches, and from all the 3 approaches we can actually see the approach 3 is slightly worse than approach 2, and you can also see why did the imputation perform better than columns. Why? Because we have got 10,864 rows and 12 columns. If we leave any column because of missing value, then we are actually leaving out a huge chunk of data that is very important, because that is very important for us to that gives the signal for the machine learning model to learn. So you are actually taking out a huge part of signal by dropping the columns that has missing value. So again, like even if anybody asks an interview, you can say this as the last option, but I would suggest you to go with other options first and then explain them when would you do something. This is one of the important interview questions that people usually ask, like how would you handle missing value? What would you do when you have missing value? Or even people would expect you to say that before I actually build a machine learning model, I would start evaluating whether there are missing values, then I would start treating the missing values, and then you come up with ideas about how would you treat missing values. So this is something that people usually do, and you should pay more attention about how to handle missing values. Lot of different ways, and even when it comes to missing value, so there are a lot of different ways of identifying missing values. So whether it is missing at random or missing with some pattern, so there are different strategies. I would suggest you look at it, but for now this would do good. Now that we have learned the three approaches how to handle missing values, let's go to our exercise and then do it ourselves. The new notebook has loaded. Let's start the session. And in this session, let me run the code and let me run our default code. I'm not going to explain this code again because we have almost by this time know what is happening. So the preliminary investigation, just don't do anything, just run it. It would tell us that how much missing value that we have got. So what are we trying to do? We are trying to first, we're trying to identify the shape of the training data set, which is after the the split 80% 20%. After that, we are trying to identify the missing values, and then we are trying to get an estimate of missing value count by column. So we are trying to find out for each column how much missing values that we have got. So first you can see these columns, like in this column we have got 212 missing values, in this column we have 6 missing values, in this column we have 58 missing values. There are certain libraries that will even give you percentage and a very nice chart about how much missing values we would get. So like percentage of missing values, that is again a decision point. Sometimes people tend to say, like, if you have more than like 15% missing value, 20% missing value, it's very hard to impute missing value, then you have to leave. So there is no industry standard, I would say, like, but a lot of people debate with 10% and 20%. You just have to look at the business context and then make a call whether you have to drop, you want to impute. If you want to impute, how do you want to impute? And that's what we are going to do now. Okay, so how many rows are there in the training data? Simple answer, this is how many rows. How many have missing values? Number of columns with missing values 1, 2, 3. Number of columns with missing value, 3 columns have got missing values 1, 2, 3. Okay, so and how many columns are there? 36 columns. And the total missing values, how many missing entries are contained in all of training data? So do I have to sum everything? So 2 entries, which means they're asking about data points, number of data points. So 212 plus 6 to 18. Is it how many entries? Okay, 218. Okay, basically I can even sum if you want, but we'll just do 18, and 56 is 218 plus 56 is 276. 276. Run it. Correct, everything is right answer, but yeah, it's a very crude way of calculating this, but that works. So part B, considering your answers about what you think is the likely best approach to dealing with missing values. So now that we have only 3 columns, you can try dropping as well onto only, because one column has slightly good missing values, but if you look at this column, it has only 6 missing values, but if you start dropping, like an entire column would go. So maybe that is not a good approach. So let us go. So this check. Correct, since there are relatively few missing value entries in the data, the column with the greatest percentage of missing value is less than 20%, so we can expect dropping columns is unlikely to yield good results. This is because we would throwing away a lot of valuable data. So like I said, so usually industry, they argue about like having less than 20%, more than 20%. So basically the decision that we have taken is because it's less than 20% missing value, we might have to start imputing the value. and this is a function that we were using before, different data sets. So again we are going to look at different methods. And how are we going to do that? So in the first step, you will pre-process xtrain and xvalid, and the first step is we need to get the column names where we have got the missing values. I think this column name might be already there, but you can, for simplicity, I would suggest you can just copy the code from here and paste it like this. This is the same code, but if you do not want to copy, that's completely fine, but this is the easiest for you to do. So just copy and paste it. Did I just delete the column? Okay, they have not given me the column name. So we can say call with missing. So you can, this is using list comprehension. You can still use for loop if you want, but list comprehension would come easy. So if I want to quickly show you how this list comprehension is built. So for example, first let me say this. So what will this do? Did I just, okay, call is not defined. Okay, first we have xtrain. Okay, for xtrain, if you take a particular column, in this case, let's take a column where missing value is there. The column name is, let's say this is the column name. If you put the column name where missing value is there, and then if you say is null any, so it would say true because there is a missing value. If I have to look at some column name where missing value is not there, for that first I need to get the column names, columns. If we get this, then let's say garage cars, lot area. Does lot area has a missing value? Let's see, lot area. Then you know you got false. So whenever there is a missing value, it's going to say true. Whenever there is a missing, whenever there is not a missing value, not even a single, is going to say false. So now what we are going to do is we are going to take this and iterate it for every column. For every column value, we are going to see if missing value is not there. And whenever missing value is there, we are going to return that column name. So basically at the end of this process, we are going to have these three column names. You can see three column names. And now that we have these three column names, next step is for us to drop these columns from the training and test data. So what is our train and test? So our train, because we have split, where have we split? This is our train, xtrain, xvalid, ytrain, yvalid. So now we have to drop the missing values. Again, simplest is you can go here and then copy the code, come back. It's better you write it yourself, but yeah, if you are slightly lazy to write, you can just copy paste it. Again, there is no point in memorizing the code. You can always go online and then look for the code. The most important thing that you need to understand is, do you know what to do at this point? That's the most important thing. So my name is calls with missing, calls missing, and then when I run this thing, it's going to say correct because I have just dropped it. And after we drop the columns, it's just to make sure that our access is intact. That's what we are doing. And then after we do that thing, we are going to check the mean absolute error, and we have the value. So basically we just replicated whatever we have done here, and then we have the final output. The remaining section, I would request you to do it yourself so you get the practice. So basically you just have to almost copy or paste it here, or you can just Google online and then get the result. So basically what you're trying to do is you're trying to compare the three approaches and then finally see which approach is better, and then you submit the best approach to the competition that should ideally improve your scores. So submit it. If you have any issues, please let me know in the comment section. I'll try to help you out. Now that we have learned about missing values, the next thing that we are going to look at is how to handle categorical variables. Now before even we move into this, now you might ask me, like, what is a categorical variable? Anything that is not a number is a categorical variable. That's what I would start with. Anything that is not a number is a categorical variable. Now this categorical variable I would classify into two categories. Okay, so first I said anything that is not a number is a categorical variable, and now I'm going to split this categorical variable into two categories. One is called an ordinal variable, the second one is called a nominal variable. What is a nominal variable? A nominal variable is a categorical variable where there is no order. For example, if you have a university data, and in that university data you say like assistant professor, professor, senior professor, then you know like assistant professor is always lesser than professor, professor is lesser than senior professor. Same like, you know, assistant engineer, senior engineer. So now this is a categorical variable, but still it has an order. It's like low, medium, high, it has an order. So this is an ordinal variable, like categorical variable of type ordinal variable. Now let us say that you have two categories or three categories like this: red, yellow, green. So now let us assume that in this red, yellow, green there is no hierarchy, no order. So which means this is a nominal variable. So categorical variable, nominal variable are variables, anything other than number, but not like a proper noun. It's not like a proper noun. Let's say like you have got an ID variable, which is not a category, which is not a number. Now you cannot say it a categorical variable. So it's a character, but still it is not something where you have limited set of values. It's not like something you can group your data set by. So it is like a proper noun. You have got like all kind of, like if you take a name list in a class, that is a proper noun. So that is not a limited number of values. But what would be a limited number of values? Let's say in a class you have got people who have taken a particular specialization, or people who come from a particular set of places. Now this is a limited number of variables where you can group your data set by. So this kind of categorical variable we are splitting into two: ordinal and nominal. Ordinal is where you have got an order, nominal is where you have got no order, like everything is like individual. Now based on what kind of variable that we have got, whether ordinal or nominal, so we have three approaches. One of the approaches that they have said is like drop categorical variables. Some people still do it, like a couple of machine learning models will not support categorical variable, and that is why we are dealing with this. Like some of the machine learning models will not deal with categorical variables. That's why we are trying to learn how to handle them. So drop the categorical variable. Some people still do it for building a baseline just with numerical data because it's easier to do it, but that's definitely not the efficient option. Again, like everything else is like a single line of code. So if you want to still try with this, that's completely fine, but that's not usually advisable. So the next approach is called ordinal encoding, where for every level of category, because there is an order, you are going to assign a number. Like I said, to give you an example, if you have got assistant engineer, senior engineer, then assistant engineer would get 0, engineer would get 1, senior engineer would get 2. So depending upon how many levels you have got, for each level in increasing order, you would set an integer value so that you know, okay, never, which is 0 is less than rarely is less than most days is less than every day. So you know that there is an order intact while you are even giving this number. So this is again based on the assumption that you have got category, you have got order within these categories, and then because you keep the order intact, so which means like even if you are encoding it, so that order is intact. And for many models, which is especially like tree based models like decision tree and random forest, ordinal encoding works well with ordinal variables. Now what is the next category? Because what if our categorical variables are nominal variables, not ordinal variables? What if there is no inherent variable, inherent order in place? Then that's where a very popularly used concept, like most popular, almost like everybody uses it, and almost like in every interview they ask this question: how would you handle this? And then your answer could be like one hot encoding. There are a lot of other encoding options as well, but yeah, one of the most popular, like a lot of people use, is one hot encoding. What is one hot encoding? It's quite simple. For each level in your categorical variable, you would create a column and then you would assign a boolean value whether it is true or false. Like if you have a categorical variable, like a column like this, which says like you have 5 data points, 1 2 3 4 5, and these are the values that it contains. What you would do is you would kind of, you know, like how you would do long to wide, so almost like that, you would create these levels as new columns and you would assign a boolean value which is 1 or 0. Why did I say 1 or 0? Yeah, boolean values but numeric, 1 or 0, and then you would say okay, red is 1, but yellow is 0 0, green is 0 0, here it is green. So you would make something like this. And so this way, instead of doing an ordinal encoding, because there are no levels, if you say 0 1 2, it might look wrong because you're trying to enforce an order that does not exist, but rather than that you would actually go with one hot encoding, which creates new columns. So as an information, one hot encoding does not perform well if the categorical variable takes a large number of values. For example, let's say we have like 15 categories, like 15 values. Let's say it's a state in India, or a district, or something else. So now a province if you are outside India. So now it may not make sense for you to use one hot encoding, because like you would end up creating a lot more columns, and there you would probably get a new problem called curse of dimensionality. So categorical one hot encoding is preferred when you have less number of levels in the categorical variable, and it is one of the powerful methods that people usually use. Now that we have already seen the theoretical part about what are the different ways we can treat categorical variables, which is one, drop the column, second, ordinal encoding, third is one hot encoding. Now we are going to look at how the performance looks like. It's very similar what we did in the previous section. So first we are trying to get the list of categorical variables. Quite simple. When we do the data frame .d types, it's going to give us numbers and categorical variables. Whenever you match it with object, it's basically categorical variable. So we can see that in this data set we have got 3 categorical variables: type, method, region name. One thing that you might have to notice is this object might also give you proper noun. So whenever it is also proper noun, it might give you. So that's something that you need to be conscious about, because you don't want to take a proper noun that has like if your data set is 10,000 data points, you don't want a categorical variable with like 9,000 data points and then start 9,000 levels and start using it. So be cognizant about it, like that it might also show that. Okay, so the next thing is we have defined the score data set, which is to compare 3 different approaches. Our evaluation metric still stays the same, mean absolute error. Now what we are trying to say is, the first step is we are saying basically exclude the columns of type object. So that's what we are saying. Select D types. There's a function, method. So when you use that, you can say exclude these types, and then basically you have excluded the all sort of categorical variable. I mean, like you have just retained the number. So and then you have kept this. And then you have calculated the machine learning score, which is MAE in this case, which is like this is the score. And the second one is you are trying to use an ordinal encoder. So there is a submodule called scikit-learn pre-processing. In that you are importing an ordinal encoder, and then again to avoid changing the original data set, you make a copy of it, and then you do ordinal encoder fit transform, and then you give the data with the object call. So object call is something that you created here, right? So this is the list of column names where you have got categorical variables, and then you are trying to fit, so that at the end of this process, here you would actually get not the categorical variable, everything would be numerical variable with the ordered number, like ordered encoding. And once you do that, you can actually score. So when you score it, you can see the comparison, like you have got 175,000 here, and now you have got 165,000. That's a huge improvement. Again, re-emphasize the same point that dropping a column or dropping anything is a terrible idea. So it's always good to approach them. And now that you can see again, so for example, we have not provided custom labels, so it's up to you. So just assigning random integer is easier, but if you assign custom values like labels, like we assigned here, like in this case, it might actually give you better results. So it's up to you to do that. So the next thing is the one hot encoding. Again, one of the most popular methods that is usually used. In one hot encoding, when we want to do, we set handle unknown is equal to ignore to avoid the errors when the validation data set does not contain or contains the classes that are not there in training data. So what you can imagine is, for example, you are splitting your train and test data for validation, train and validation data. Imagine your train data contains only 3 and your test data contains 5, which means your test or validation data set contains extra levels that are not present in your train data. So that might that might throw an error. So to avoid that, you are just saying that basically handle unknown, just ignore it. When you see anything that is unknown, just basically ignore it. That's what you're saying. And if you have a sparse matrix, then you would say sparse, like setting sparse equal to false will ensure that the encoded columns are returned as a numpy array, not a matrix, sparse matrix. So numpy array is what we want. So we can convert into pandas data frame and then add the columns, and then we can use it for a model training purpose. So now that we have learned how to use Hot Encoder, which is from SQL and pre-processing. If you see this same thing, it also came from pre-processing. So you now know that the submodule pre-processing has these things that will help you do pre-processing before building a model. And again, this is something that most likely people would ask you during interview, saying that, okay, so how are you going to handle categorical variables? What is the difference between ordinal and Hot? What other encoding methods exist? Why would you use Hot? Why would you use ordinal? So these things you should keep in mind, or you should prepare more after this video or class or this notebook, because that is important for you to know. So we have defined one Hot encoder the same way like every time we define on scikit-learn with these parameters that give me a numpy array and give me like ignore any unknown. And then now that our encoder object is ready, we are going to say of all these columns where we have got object value, just fit. And now you know that these are the columns. Please note that these are the columns where we had categorical value. So if you notice, this is not the entire data set. These are the columns or the data set where the columns only had categorical variables. And now we are putting the index back. After we put the index back, now we are actually remove the columns or categorical columns from the original data set. So this is columns with categorical values, and then we are creating that. Now because we have already encoded these, we are dropping the original columns for which we created the encoding from the original data frame. Okay, now that we have done this thing, we can use concatenate function method to concatenate these two. So this is one numpy, like this is like an array, this is like an array. So we are going to combine these two columns, like probably like let's say like if you have removed one column with two categorical values in it, so here you would get two columns. So now that with the remainder of your main training data set, you are going to concatenate, and then you are going to store training and validation. OH is just simply to say that you have done Hot encoding. Now you are going to test the approach where score dataset, the new encoded training and validation X, and then you're going to compare it with Y train and Y valid. The score is something that has not improved a lot. You will see 165, 166, like very little difference between these two, but usually Hot encoding. So here you would see these two are close, but usually Hot encoding actually performs best, and dropping the columns is one of the worst methods to do. So Hot encoding, and also look for other encoding methods that will help you understand what kind of encoding options exist, and you need to actually say which one would you use when, because if you know I want to use Hot encoder, you can just simply go say scikit-learn Hot encoder, and you would get example, you would get function, everything. You can get it, copy and paste here, like as simple as that. But you need to actually know which encoder to use. So that is why it is important for you to know when to do what. Now that we have learned the three approaches to handle categorical variables, next we can jump into the exercise. I'm not going to do the exercise for this thing because like we did previously, you have the code for everything already. Kaggle has been kind enough to give you the code, so you can just copy the code and paste it, or you can Google and get it, or you can type it yourself, whichever is your easiest option. You can do that and then complete this. So please remember that only when you complete your exercise, you are going to get the Kaggle certification. Otherwise you may not get Kaggle certification. But if you are stuck while doing the exercise, please let me know in the comment section. I will try to help you. So in this video, we learned three important things, which is first, introduction to intermediate machine learning. We just quickly revised what we learned in the previous videos, and then next we learned about how to handle missing values. Next we learned about how to handle categorical variables. So in the future section, we'll learn about pipelines, which is to make the way we write this modeling code in a slightly better way. So it has a lot of advantages. Let's look at in the next section. If you have any question, as usual, please let me know in the comment section. Otherwise, share me your feedback and share this video with your friends. Stay safe. Happy Kaggling.